And then we will continue with the next combination. But here I will write chi square as a method for testing of hypothesis, and Cramer's V as coefficient for the strength of relation. So next cells in the first row, nominal or ordinal independent variable and interval dependent variable. Again, I will add here additional row, and when dependent variable is nominal or ordinal, it will be optimism, but optimism R, optimism measured in three categories: below the norm, in the norm, and above the norm. And when the dependent variable is interval, then the dependent variable could be optimism, or optimism average, or Z optimism, or T optimism, or index optimism. All these variables are interval variables, and we could use them for the analysis of relation. But for our examples in the presentation is chosen, let's see, is chosen optimism, the basic variable for optimism, the row scores of optimism. And again, the independent variable will be Merishal status. So this is the same relation, but in the first case, we measure optimism as ordinal variable in three categories: below the norm, in the norm, and above the norm. And in the second case, we measure optimism as interval variable with row scores. So let's make this analysis in PSPP. So I will choose analyze, then compare means, then ANOVA. Why ANOVA? Because the method here is called analysis of variance. Analysis of variance. And you can see here that ANOVA is analysis of variance. So I will choose here analyze, compare means one way ANOVA. And then dependent variable is optimism. And factor is Merishal status. Here we have different fields for dependent variable and for independent variable. After that, I will choose here descriptives and press OK. Okay, this is the result. Sorry, I have to unsplit the file because now the file is splitted and we have different results for males and females, different results for males and females. I must unsplit the file, so I will choose data, split file, and then analyze all cases, do not create groups, then OK, and then I must repeat the analysis, the compare means ANOVA. So analyze, compare means one way ANOVA, and just press OK. So here's the result. First, here we can see average scores for each group. And here we can see that in the group of without, average score is highest, is largest. And also in the group separate, average score is lowest. So without are most optimistic and separated are less optimistic. But our first task is to obtain whether there is relation or not. So it is possible this difference to be these differences to be smaller than sampling errors. So we need testing of hypothesis, and the method I already said is analysis of variance, and here we have a significance level. This significance level is 1.8%. This is smaller than 5%, so we must accept the alternative hypothesis again. That means that the differences between different Merrill statuses are statistically significant. That means that there is a relation between Merrill status and optimism. And this was the first task, presence or lack of relation. The second task again is to analyze the direction of relation, but again our independent variable is nominal. Since the independent variable is nominal, it cannot increase and we cannot analyze the direction. And again, for the example, I will change the independent variable and I will choose education again. So I will repeat, analyze, compare means one way ANOVA, and we'll move Merrill status in the left, and we'll move educational level in the field factor. then press again OK, and let's see the result. So here we have mean scores in each group, and we can trace the direction. So educational level increases from primary to postgraduate completed, but mean score decreases, after that increases, after that decreases again, after that increases, and after that increases again. So we are in the third situation. Mean scores goes up and down, up and down. So this relation has no direction. And of course, here the significance level is 34.5%, which is larger than 5%. So our conclusion is that we must accept null hypothesis. That means that there is no relation between educational level and optimism. But if there was a relation between educational level and optimism, this relation has no direction. So the third task is to measure the strength of a relation. And again, we will use coefficient. Coefficient now is called correlation ratio. And for this correlation ratio, we use Greek letter eta. Like this. But eta square is called coefficient of determination, and usually we prefer this coefficient of determination because coefficient of determination shows percentage of variance of a dependent variable, which is explained by the independent variable. Unfortunately, in PSPP, we cannot compute this correlation ratio or coefficient of determination. We cannot compute these coefficients automatically, but coefficient of determination is easy to compute since we have these two values. We have sum of squares between groups and sum of squares total. And if we divide sum of squares between group by total sum of squares, we will obtain the coefficient of determination. So I will use calculator. Yeah. And we'll divide 110.31 divided by 8,513.02, and the result is 0.03. So eta squared is 0.013. This is 1.3%. That means that 1.3% of variance of optimism is explained by Marischal status. Also, we can calculate another coefficient. It is called coefficient of indetermination. It is 1 minus coefficient of determination. And in our case, this coefficient is 0.987 or 98.7%. That means that 98.7% of variance of optimism are explained by all other possible factors. So our factor, in the example, Marischal status explains 1% of variance of optimism, and all other possible factors explain 99% of the variance of optimism. So that means that the relation is very, very, very weak, because only 1% of variance is explained by the factor. Of course, here we can calculate also correlation ratio. This is eta. This is square root of eta squared. In this case, square root of 0.013, and the result is 0.114. 0.114. Again, we can use intervals for Cramer's V. That means that if eta is between 0 and 1/3, the relation is weak, and if eta is between 1/3 and 2/3, the relation is moderate, and if eta is between 2/3 and 1, the relation is strong. And again, in our case, this value is between 0 and 1/3. That means that the relation is weak. different coefficients, but all show that the relation between Merishov status and optimism is weak relation. So these were all three tasks: presence, direction, and strength. And now, but I made mistake because I calculated the eta squared for the educational level, not for Merishov status. So let's do it again for the Merishov status. For the Merishov status, between sum of squares between groups is 329.26 and divided by 8,513.02. The result is here 0.39 or 3.9%, and coefficient of determination will be 0.61 or 96.1%, and the correlation ratio will be 0.197. Our conclusion will be the same because almost 4% of the variance of optimism is explained, are explained by Merishov status. Almost 96% of variance of optimism are explained by all other possible factors, and 0.197 is between 0 and 1/3. So our conclusion will be that the relation between Merishov status and optimism is weak. So now I will show you chart, but again, this chart is possible only in SPSS. In PSPP, there is no charts for the ANOVA. And this is the chart again, like yesterday. These points here, these small circles represent average score, average scores, average means, and these whiskers represent sampling errors. So yesterday I said that if the difference between means is smaller than the errors, then this difference is not statistically significant. And in the opposite, if the difference between means is larger than errors, then this difference is statistically significant. And that means that there is relation. So here on this chart, we could see that maybe between single and a steady relationship, there is no statistically significant difference because the difference between means is smaller than errors. Also, for the uh, group of steady relationship, groups of steady relationship and living with partner, again, the difference between means is smaller than the errors, and so on and so on. So maybe uh, uh, there is statistically significant difference between separated and without, maybe, or maybe there is statistically significant difference between separated and maybe there is statistically significant difference between separated and divorced. But maybe, I'm not sure, but we can test this hypothesis, and here we can use so-called post hoc test. Post hoc test means comparison in each pair or pairwise comparison. So we can compare each group with all other groups. And first, I will show this analysis in SPSS, and then we'll perform in PSPP. Because in SPSS, there is one preliminary step, and this preliminary step is checking of homogeneity of variances or checking of equality of variances, and we have here this option, homogeneity of variance test. In PSPP, this option also exists. If I choose analyze, compare means one way or another, here we have homogeneity tests. And I will press here, okay? And we have additional table here for test of homogeneity of variances. And again, there is significance level. This significance level is 11.3%. This is larger than 5%, so we must accept alternative hypothesis. Sorry, since the significance level is larger than probability of type 1 error, we must accept the null hypothesis. That means that there are not differences between variances in all groups. But again, I made mistake because I didn't change the independent variable, and dependent variable again is education. So I will repeat this analysis again. Compare means one way or another, and we'll move education to the left, and we'll move marital status in the field factor. So now the significance level of the test of homogeneity of variance variances is 0.967 or 96.7%. This value is larger than 5%. That means that we must accept the null hypothesis, and that means that the variances in all groups are equal. After that, in SPSS, we must choose post hoc test, and here different methods are separated into groups: equivariance assumed and equivariance not assumed. But in PSPP, different methods are not separated in groups. So when I choose compare means one over, here we have a button for post hoc tests, but these methods are not separated in groups. So we must see here the groups, and PP Bonferroni method. Bonferroni is here, equivariance assumed. James Howell is here, equivariance not assumed. Fisher's least significance difference, LSD. LSD is here, equivariance assumed. Sheffe is also here, equivariance assumed. Shidak is here, also equivariance assumed. And Tuki is here. There are two coefficients of Tuki and Tuki B, but both are in this group, equivariance assumed. So only different James Howell is used when the variances are not equal. If the variances are equal in all groups, then we could use other coefficients: Bonferroni, Fisher, Sheffe, Shidak, and Tuki. And in psychology, the most popular coefficients are Bonferroni, Sheffe, and Tuki, and I will check them. After that, continue. After that, okay. And let's see the result. So here we have table with multiple comparisons for the three different methods. First, Bonferroni, after that, Sheffe, and after that, Tuki. And here we have pairs. First, we compare single and steady relationship. After that, we compare single living with partner. After that, we compare single with married first time, and so on and so on. And here, in this column, we have significant levels for each pair. And if the significant level is larger than 5%, then there is no statistically significant difference in this particular pair. And if the significance level
I can't hear anything. Is everybody else okay?
I also cannot hear.
Also cannot hear anything.
I was thinking that is my connection, but it's not.
Yeah, I thought so too, but it's not.
I think the professor has dropped or was dropped from the call.
We can only wait. We come back in the same meeting. Which is the link.
Okay, I'm here again. There's a problem with my home internet, but do you hear me now?
Yes, but we were not hearing maybe the last couple of sentences. So.
Okay, I will repeat the last sentences.
Hepsi şeyde alt çekmecedeki göz. Aynen öyle. Çekmeceyi koyacağım. Yo istiyorsan siyah. Ya da sadece ekmek. Hepsini alabilirsin. Varsa Brez var ya onların arasında. İstiyorsan al. Tazeyse ama yumuşak.
Merve, your microphone.
I can't hear you.
Sorry.
Okay. So before the break, I said that in this table we can see the pairwise comparisons, and in one table the results of three different methods are presented. First Bonferroni, then Cheffet, then Yuki, and the pairs are here. We compare single with steady relationship, then compare single with living with partner, then compare single with married first time, and so on and so on. And in this column are significance levels for all pairs. And if the significance level is larger than 5%, then in this particular pair, there is no difference. There is no difference between these two groups. And if the significant level, significance level is smaller than 5%, then in this particular pair, there is statistically significant difference. So let's see. Okay, only this significance level is smaller than 5%. This significance level is 3.2%, and the pair is separated and without. So there is statistically significant difference between separated and without, and we can see this on the chart. On the chart here, statistically significant difference between separated and without. And this was this significance level. Here we have again 3.2%, but this is the same pair because here we have separated and without, and here we have without and separate. But this is the same, only we only have changed the places of groups. Here separated first, without a second, and here opposite, without a first, separated a second, but the pair is the same. So this were results from the Bonferroni method. For the Cheffet, there are not values which are smaller than 5%. So according to the Cheffet method, there are not statistically significant differences in all pairs. And for the Tukey method, here we have 2.5%. Again, for the pair of separated and without. So, according to the Tukey, there is statistically significant difference only between separated and without. When I said maybe there is statistically significant difference, or maybe there is not statistically significant difference, we can check this. We can test this with post-hoc tests, and the final conclusion is that the only one statistically significant difference is between separated and without, only between these two groups. And this was analysis of variance, and this was analysis of relation between a nominal or ordinal independent variable and interval dependent variable, but with only one independent variable. Since now is 11:30, that means that it's time to break. I will stop here, and I will continue with additional independent variables after the break. But before that, here I will write another as method for testing of hypothesis, and eta squared as coefficient for the strength of relation. By the way, I forgot that in our previous case here, when we analyze a relation between nominal or ordinal variables, that if we square Cramer's V, we will also have coefficient of determination. So for the relation between Marischal status and optimism R, the Cramer's V was 0.19. So here before different groups, before males and females, we have that Cramer's V is 0.19. So V square will be 0.19 multiplied by itself will be 0.36 or 3.6%. This is coefficient of determination, and again we can compute coefficient of indetermination, 1 minus coefficient of determination, 1 minus 0.036, which is 0.964 or 96.4%, and again 3.6% of the variance of optimism are explained by Marischal status, and 96.4% of the variance of optimism are explained by all other possible factors. And here I will make new table okay. Relation between nominal or ordinal variables Did I start record? Maybe no. Okay, oh yes. I did. Okay. Nominal ordinal variables. Relation between nominal or ordinal independent variables, variable or variables, and interval dependent variable, and relation between interval variables. And here, first row, coefficient of coefficient of. After that, coefficient of determination. And in the last row, coefficients of indetermination. And in the first column, we have coefficient of Kramer's V, and coefficient of determination is V squared. This is coefficient of determination. And coefficient of indetermination is 1 minus V squared minus V squared. And the same is here in the second column. Correlation ratio is eta. Coefficient of determination is eta squared. And coefficient of indetermination is 1 minus eta squared. The letters are different. Here we use V, here we use eta. But the interpretation is the same. If we are here in the first row, then we can see that if the coefficient is between 0 and 1/3, the relation is weak. If the coefficient is between 1/3 and 2/3, the relation is moderate. And if the coefficient is between 2, the relation is strong. If we are here on the second row, we can say that the percent of the variance of the result, which is explained by the factor, by the independent variable. And in the last row, this coefficient are percents of the variance of the dependent variable, which are explained by the all other possible factors. So the columns are different, the letters are different, but the interpretations are the same. So, questions? more questions. So